So, dear students, today I want to revise the topic projectile motion. At first, we can divide based on the examination point of view the projectile motion into 6 different types. The first one, the oblique projection, means from the horizontal, that body is projected at an angle theta. The second one, the horizontal projection, means the body is projected horizontally from the top of a tower or a mountain, etc. The third one, the projection above horizontal from the top of a tower at an angle theta. From the horizontal at an angle theta below. Then the projection along an inclined plane. And the last one, projection in a moving frame. So at first we can discuss about what I mean by oblique projection. See, from the horizontal, it is projected at an angle theta. Here theta is said to be the angular projection, u the initial velocity u. And this drawing is nothing but the trajectory of the projectile. And keep in mind, in the normal cases, we have to take one assumption as there is only one force acts on it, that is nothing but the force due to gravity, that due to earth. The other forces, because of the medium, the viscosity, etc., are neglected. See, the vertical component of velocity, the u sine theta, at first goes on decreasing, becomes zero at the highest point, and then increasing in the downward direction. But the horizontal component u cos theta, as we know, there is no dragging forces horizontally. At any point, its magnitude and direction are constants. And hence we can say the vertical displacement at any time t is contributed by the vertical component of velocity u sine theta. And hence we can say after a time t, say particle takes the position here, then the vertical displacement y, we can apply our relation as s is equal to ut plus half a t square. You get the value y equal to u sine theta t minus half gt square. But keep in mind, the horizontal displacement at any time is contributed by the horizontal component of velocity u cos theta, but it is a constant. There is no acceleration or retardation horizontally, and hence we can say the horizontal displacement x takes the value u cos theta into t. So if you link between y and x, you get the very important general relation for a projectile motion, as y take the value equal to tan theta x minus half gx square by u square cos square theta. And here that y depends on x square, and hence we can say the trajectory of the oblique projection is a parabola. The very important 3 technical terms are waiting. You know, the first one is the time of flight. the time taken by the projectile to complete the trajectory. And here there is no other forces, and hence surely we can say the total time is nothing but equal to time of ascent plus time of descent. And hence the total time, the time of flight become 2u sin theta by g. And keep in mind, the time of flight become maximum when theta equal to 90 degree. The horizontal range, we know it is the maximum horizontal displacement in the trajectory, and is contributed by the horizontal component of velocity u cos theta. We derived it to be r is equal to u square sin 2 theta by g. And keep in mind, the range become maximum when the sine of the angle become maximum. There we can say the theta got the value as 45 degree. And we get the equation for r maximum is equal to u square by g. And we can express in terms of the vertical component of velocity and the horizontal component of velocity as the range is equal to, look, this equation can be written as sin 2 theta, take the value as 2 sin theta cos theta, and can be converted into this much. Maybe the very important shortcut to find the range as 2 into the vertical component of velocity into the horizontal component of velocity by g. The maximum height, the maximum vertical displacement in the trajectory. So derived it to be as h is equal to u square sin square theta by 2g, and got the maximum value as u square by 2g when theta got the value 90 degree. We can discuss the very important concept. What is the velocity after a time t? We know from the kinematic equations, the velocity at any time, we can find the value v is equal to u plus ad. You can substitute it here. Then the vertical velocity, take the value u sin theta minus gt. The horizontal velocity is free from dragging forces, and hence we can say it is equal to u cos theta. And here the horizontal and the vertical component makes an angle of 90, and its resultant velocity can be find out as equal to root of vx square plus vy square, and takes the value as equal to the root of u square plus g square t square minus 2u gt sin theta. You can find the direction by taking the tangent at any point on the trajectory, as a tan alpha got the value equal to the opposite side, the vy by the adjacent side vx, so equal to tan theta minus gt by u cos theta. So that is the velocity after a time t. Then we can move to a very important problematic situation, how we can find the change in momentum between here the starting point and the end point. You know, at the initial point, we split the initial velocity into two components, u cos theta along horizontal and u sin theta along vertical, and can be expressed in the vector form as u initial equal to u cos theta I plus u sin theta j. At the end point, you know, the vertical component reverses its direction, and hence we can say u cos theta I minus u sin theta j. Then if you find the change in velocity, you got the direction as minus j with the magnitude 2a sin theta. See, you should know the meaning of minus j. The minus j means vertically downward. You know, the change in velocity by time is said to be the acceleration. So for the projectile, the only one acceleration suffered by the body is that due to gravity, and is acting vertically downward. And here the change in momentum got the formula mass into change in velocity, and you get the equation as 2mu sin theta. Then now we can discuss what is the kinetic energy and potential energy at the highest point. You know, There is no vertical component of velocity at the highest point, but there is the horizontal component. And hence the kinetic energy takes the value as half m into the velocity at the highest point square. So that is equal to half m u square cos square theta. The potential energy at the highest point, we can use the simple equation as mgh. That is equal to mg into the maximum height u square sin square theta by 2g, and take the value as half m u square sin square theta. You can additionally think another point. If you just add the kinetic energy and the potential energy, you get the total energy, the mechanical energy, but you take the value as half m u square plus cos square theta plus sin square theta equal to half m u square. That is nothing but the initial energy. We can say the total energy is conserved. Now we can discuss the very important point, projection with the complementary angles. That means theta and 90 minus theta. That means angle 60 and 30, angle 75 and 15, angle 80 and 10 degree. And keep in mind the very important concept. For the complementary angles, keep in mind their ranges are equal. If you just find the ratio of maximum heights, you get the value as tan square theta. If you find the time of flight ratio, you get the value tan theta. Please experience by substituting the values, and this concept is very important. Keep in mind, for the complementary angles theta and 90 minus theta, the ranges are equal. Then we can move to some important problems. And here, one question. The equations of motion of a projectile are given by x is equal to 40t meter, 2y equal to 100t minus 10t square. The angular projection. So that is happened at the initial. So it is given as x is equal to 40t, and we can find the s component of velocity by differentiating one time. So you get the value as 40. From this expression, you can return the expression for y by dividing with 2. You get the relation as equal to 50t minus 5t square. You can take the differentiation, and hence we get the vertical component of velocity as 50 minus 10t. But when t is equal to 0, that is a very important point. The initial vertical velocity is given as 50. You know the horizontal initial velocity as u cos theta at 10 time, but the vertical velocity u sin theta initially as 50. And if you just divide it, you get the value for tan theta as equal to 5 by 4. That is answer. A good concept. The next one, a very important one. A particle thrown over a triangle from one end of a horizontal base falls on the other end of the base after grazing the vertex. If alpha and beta are the base angle of triangle and angular projection is theta, then we want to find their relations. How we can relate between alpha, beta and theta? Look the figure, and here alpha, beta, the height is, we can take say y, initial angle is taken as theta. From this triangular frame, you can just find the value of tan alpha is y by x. The total one is the range r, and hence this portion can be written as r minus x. So tan beta, take the value as y by r minus x. If you take their sum, tan alpha plus tan beta equal to y by x plus y by r minus x. So equal to y by so much. But keep in mind the very important concept. It's a good relation. You should memorize it always. How we can relate between y, x and r. In this relation there is no component of v. So it is a very important one. So you can use this one. Just crossing, you get the form like this one, and you get the value tan theta equal to tan alpha plus tan beta. So we can move to the another good question. A particle is projected from the ground at an angle such that after t1 time it just clears the top of a pole in its path. It takes a further t2 time to reach the ground. So one important point is there, the t1 plus t2, that is the time flight. What is the height of the pole? A good concept. So, and here one factor is there, after t1 time, that pole, it is never mentioning it is at the maximum height or not. And hence we can say at a particular time t1 what is the vertical displacement. So that y is nothing but the height of the pole, can be simply written as u sin theta t1 minus half g t1 square. But it is given as t1 plus t2 is the time of flight as 2u sin theta by g, and hence you can substitute it for u sin theta from this relation as t1 plus t2 into g by 2. You can substitute that value on this relation, you can solve it. You get the simple, it becomes simple. You get the value as a half g t1 t2. We can move with some problematic situations. If a person can throw a projectile to a maximum distance r maximum, the maximum height which it will rise is r by 4. Look the relation between r and h. If r is n times h, then tan theta take the value as 4 by n. It's a very important concept. See the horizontal projection. Look at the speciality. And here the object is projected horizontally. That means the horizontal component of velocity is u. The vertical component is 0. So its horizontal component of velocity at any time it is constant, free from the dragging forces. But the vertical component initially is 0. But at any time its speed goes on increasing. Say at a particular point P, it takes the horizontal displacement as x and the vertical displacement y after a time t. They can use our kinematic relations. Then we get the value x is equal to ud, and we get as y is equal to half gt square. And from that we get the general relation for the projectile motion as y is equal to half gx square by u square. Then from that relations we can written as the time of flight, the maximum height, that is equal to half gt square. The horizontal range is supplied by the horizontal component of velocity u in a time of flight, and hence the horizontal range x is given as u into root 2h by g. And keep in mind these relations we get easily by using a shortcut. You know all the relation for oblique projection. You know at the highest point, if we take divided into 2 half, so the right hand side half is nothing but the horizontal projection. So you know at the highest point there, the vertical component of velocity is 0, and here also 0. But in place of u cos theta it is written as u here. So if you replace all u sin theta as 0 and u cos theta as u, then you get the very important relations so easily. The velocity after a time t. So here the horizontal vx, vertical vy, then simply we can written as v is equal to u, the vy is equal to gt. They are with 90 degree, and hence the resultant take the value as u square plus g square t square. Their angle with respect to the horizontal, we can written as a tan beta, take the value as gt by u. We can move with a very good question. A relief food package is dropped from an aeroplane which is moving horizontal with a velocity of 30 meter per second at a height h is equal to 50 meter. Find. We have to answer for 4 questions. We get the horizontal projection concept in very well. The first one is the time of flight of the package. That is as simple as t is equal to root 2h by g. And the second one is the location of the point of striking of the foot package. So that is given by the horizontal velocity u in a time t. And third one, the velocity of the package at the time of striking the ground. That means the end velocity. So we can written as a root of vx square plus vy square as a root of u square plus g square t square. The next, the displacement of the foot package. So this is we have to find. So root of x square plus h square, we get the answer. Another very good question. A ball rolls off the top of a stairway with a horizontal velocity u. If each step has h height and b width, the ball will hit the edge of the nth step. Then find the value for n. You can this concept. So keep in mind a good example for a horizontal projection. You can use the general relation as y is equal to half gx square by u square, but it is given if it is with the n steps, we can say y is nothing but if one step got a height h and can be written as nh equal to half g into x. If it is with the n steps, we can written as nb square by u square, and you get the answer. A good concept, that is application of horizontal projection. Good, a simple concept. Projection above horizontal. In the last section we discussed what is a horizontal projection. But here, in the horizontal projection, it is projected at an angle theta from the horizontal, but from the top of a tower. We have to follow the concept, the same pattern. It is a two-dimensional, and hence the initial velocity can be split into two, the u cos theta and u sin theta. And keep in mind, the horizontal displacement at any time is contributed by u cos theta, and the vertical displacement from it is given by u sin theta. So if you just take this the point, then if you find the movement of the vertical component, it must move like this one. If you just find the movement of the u cos theta, then it must move like this one. That is like this one. So with respect to this point, this is the negative displacement is equal to the initial velocity u sin theta into t minus half g. X is nothing but equal to u cos theta into t. Vx, u cos theta, Vy, and we can express v square equal to u square plus 2gs. So easily you can find the velocity at the end point. So these equations of motions, that is very important. We can go with a good question. A ball is thrown from the top of a tower with an initial velocity of 10 meter per second at an angle of 30 degree with the horizontal. If it hits the ground at a distance of 17.3 meter from the tower, the height of the tower is. So here the x is given. We have to find what is the capital H. You can write the relevant relation for that. So we get the value. The horizontal displacement is contributed by u cos theta. So from that the time we can find it easily. Then for the vertical motion, we can written as, so you get the answer h is equal to 10 meter. A good concept. Look at the fourth case, the projection below horizontal. So it is projected in this, actually thrown at an angle theta from the horizontal. So similar package. That initial velocity u should be split into two components, u cos theta horizontally, vertically u sin theta. So we can return that equation of motion. Yes, the horizontal displacement, the velocity horizontally, simple. Then this relation, again the velocity at the end point as u square plus 2gh with root. So same equations of motion we can use it. A good question, a good question for JEE and for a very difficult NEET questions. At the same instant, the two boys throw ball A and B from the positions shown with a speed v0 and kv0 respectively, where k is a constant. For what value of k balls will collide? A good concept. So look at the figure and all the informations are there. Both the projections are separated by a vertical separation of h. And you see, like in the previous cases, and keep in mind, here, as there the horizontal displacement is the same, which is equal to d here, so their horizontal component of velocity will be same. So for this projection, we can split that kv0 into two components. So the horizontal component become kv0 cos theta 1. It should be equal to the horizontal component of this projection. So here it is nothing but v0 sin theta 2. Then you get the value for k. A good aspect. Another very important higher concept, the projection up the inclined plane and down the inclined plane. We can sense the relations so easily. So suppose here an inclined plane of inclination beta and is projected, keep in mind, at an angle theta from the horizontal. So with respect to the plane, the angle of projection become theta minus beta. See, the easy method is this one. You just take the xy z as the plane, the x-axis as the plane. This is the vertical component. So it becomes so easy. We can consider as our normal case. But keep in mind one special case. If you just find at any point the g value is acting vertically, we can split into two. So keep in mind, here it is suffered with the two accelerations. Along the y direction there is a g cos beta. Along horizontally there is a g sin beta. So keep in mind, here with respect to the plane, the angle of projection becomes theta minus beta, and the vertical component of g perpendicular to the trajectory is g cos beta. You must think about these two factors. The angle of projection with respect to the plane is theta minus beta, and the perpendicular component of gravity is g cos beta. Then we get their relations so easily. Time of flight, the normal case is 2u sin theta by g. Here theta is replaced with theta minus beta, and the component of g become g cos beta. The same concept we can use for h also. U square sin square in place of theta, theta minus beta by 2 into in place of g, g cos beta. The range along the inclined plane. And keep in mind, for the normal cases, the range become maximum when theta equal to 45. But here you have to account the inclination. So pi by 4 plus beta by 2. If you substitute this value on this relation, you get the maximum range as equal to u square by g into 1 plus sine beta, and is a very important concept, maybe a previous question. So another 5b, if it is projected down the inclined plane from the top of an inclined plane. So here also the point of projection is taken as the origin, then that inclined plane is taken as the x-axis, the vertical as the y-axis. See, it is projected with respect to the horizontal and angle theta always. So the down, the angle is taken as minus b, here beta. Then the situation becomes so easy that u can be split into two components. The horizontal component become u cos theta plus beta, and with respect to this point you can say it is u sin theta plus beta. Then you can use the same concept. The time of flight is 2u sin, in place of theta here theta plus beta, and in place of gravity g cos beta. That's all. And in this case, down the plane, keep in mind the range become maximum when pi by 4 minus beta by 2. And also that R maximum got the value as u square by g into 1 minus sine beta. A good aspect. And see, a very good question is waiting. A body falling freely from a given height capital H hits an inclined plane in its path at height h. As a result of this impact, the direction of the velocity of the body becomes horizontal. For what value of a small bet by capital H, the body will take maximum time to reach the ground. So we can easily approach the question. So look at the graph, the inclined plane, the drop from a height h. By traveling h minus h, it become a perfect horizontal projection. So at first we can find the time of fall as a root of 2 into capital H minus h by g. Then the horizontal projection, so root of 2h by g, the total time. But to get the value of dt by dh, it should be maximum. So we differentiate it, equate to 0, and we get the answer. A good concept. Another question. A particle is projected from the bottom of an inclined plane of inclination 30. At what angle should the particle be projected to get the maximum range? Up the inclined plane, no doubt at all, we get the relation pi by 4 plus beta by 2. So projection in a moving platform. And suppose here a scatter device is here and it moves with the velocity v, and a person is throwing a ball in the vertically upward direction. And keep in mind, with respect to the man, we can that the projectile seems to be a straight line motion, but for an observer outside the system fields, it is a perfect parabolic. And keep in mind, here, even though with respect to the person, the horizontal velocity of the particle is 0, but we have to consider the horizontal velocity of the skater. And here, it is projected at an angle theta from the horizontal. So the horizontal velocity, we have to take u cos theta, but plus the device velocity v. But if it is projected at an angle in the backward direction, and here the u cos theta and v, the velocity of the device are in opposite direction, so have to consider. We can move with a good question. A man is standing on a rail car traveling with a constant speed of v equal to 10 meter per second. He wishes to throw a stationary hoop 5 meters above the height of his hands in such a manner that the ball will move horizontally as it passes through the hoop. He throws the ball with a speed of 12.5 meters per second with respect to himself. So he throws it, it enters into the hoop in such a way that it moves horizontal. That means we can say that 5 meter, that point is nothing but the maximum height. We have to answer for 3 questions. What must be the vertical component of the initial velocity of the ball? How many seconds after he releases the ball will it pass through the hoop? At what horizontal distance in front of the loop must he release the ball? And we can say the vertical component is nothing but equal to u sin theta here. The horizontal component is nothing but we have to add the 10 also. So u cos theta plus 10. But here for the projectile, that 5 meter is said to be the maximum height, and hence it is so easy to find the value of u sin theta. From that we can find the value sin theta. So the time of flight becomes 2u sin theta by g. So the horizontal distance, it can be easily find out as equal to 17.5. So it may be the very important topic. So do maximum problems. God bless you. Take care.